ninth graders. We are today moving on from distribution, and what we're really getting to the core of what this unit is about, which is the anti of distribution. So we've got distribution where we've got these pieces and we're multiplying them out and we're expanding them. And now the goal is to take these fully expanded pieces and now shrink them back down. So you're going to learn a lot of different ways to do an anti-distribution, or what we call factoring. You're going to find a lot of different ways within these next couple lessons of how to factor, and they're going to get really, really jumbled in your head. So your job is to, as you're going through and learning about these, write about some things that make sense. As I'm saying it, I'm like, okay, with greatest common factor, we're looking for things that are shared between terms, things that are shared between these two terms, like a 2 is shared between these. A 2 can go into here and a 2 can go into here. They also share an x. So things that you're trying to look that are in common between terms would be something that you're looking for greatest common factor. So you should probably write that to the side as I'm talking. So things like that are going to be really helpful, because that's the hardest thing that most students have. The thing that their hill that they have to kind of climb over is figuring out which factoring technique to use at what point. So keep that in mind as we're learning. The first anti-distribution skill that we are learning in this is your greatest common factor. It should always be the first thing you do. The first factoring that you do. We're going to learn many different ways to factor, and sometimes you use multiple different ways to factor in the same problem. You should always look for greatest common factor first. And as I said earlier, we're looking for things that are shared. For instance, a 2 can be multiplied into this. And since factoring is really what we're thinking about division and pulling things apart and pulling factors apart, we're trying to divide out a 2. Something else that they share is an x. So I'm going to divide out an x. At this point, you have to worry about what is left. And how you find what is left is you take each of those terms and divide it by what you factored out. You do not always have to write it like this, but that should be the thought process that's going through your head of 4x squared divided by 2x. So we have 2x out here. 4 divided by 2 is 2. X squared divided by x is x. Minus 6 divided by 2 is 3. And x divided by x is just 1. So it goes away. And this is what we're left with. You can always double check your answer. Double check by distributing back in. You can go 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. And you can always double check and say, oh, yes, I did it correctly. Awesome. Box it. Here we go. We are going to try again. What are some things that we know are shared within these two terms? What are a few things that you think you can pull out? So we should be able to see that there's a 3 that goes into here and a 3 that goes into here. So you could pull out a 3. We also have 1a here and 4 a's here. A times A times A times A. So we have 4 of those a's being multiplied together. But since we only have 1 here, we can only take out 1 of those a's. Whereas here we have a b cubed, and here we have just a regular b. That is we can only take out 1b from both of those terms. So that is the common factor. That is the greatest common factor, and that is what we pull out. So now we go back through and divide out. 3ab cubed divided by 3ab. The 3 goes away, the a goes away, and all we're left with is b cubed divided by b, which is b squared. Now we're dividing out of this. 9 divided by 3 is going to be 3. A to the 4th divided by a is a cubed. And b divided by b is just 1, so it goes away because multiplying by 1, you don't really write down. Again, you can double check and distribute out, and that will be our final answer. Our last problem that we have in terms of greatest common factoring can be a little tricky But just realize that we have one term here and one term here. And we're trying to find what is something that they share. And what they share here is y plus 4. Y plus 4 is shared in both of them. So you can take it out as a greatest common factor. And then once you divide it out from each of those pieces, y plus 4 divided by y plus 4 just goes away. So all you're left with is x minus the y plus 4 divides out of here, and all you're left with is 7. And that is your greatest common factor factoring. All right, next way of factoring is something called the difference of two perfect squares. Now the difference of two perfect squares we have talked about in class together. Remember that when we had something that looked like y plus 6 times y minus 6, and we FOILed it out in class, and what we ended up getting was this y squared, then we had plus 6 minus 6y, and then minus 36. And those middle terms went away, and all we were left with was the square of the first term minus the square of the second term. So it's two perfect squares here, and it's subtracted, or it's separated by a subtraction, which means it is a difference of two perfect squares. And that is what it is called. So what you're trying to recognize here, when you're trying to figure out which factoring technique do I use, you're looking for, is it only two terms? That's a good indication that you should be using the difference of two perfect squares. And if it is only two terms, one term, two term, then are each of those terms perfect squares? X squared is a perfect square, and 25 is a perfect square. And then you just have to remember what happened at the beginning. What happened at the beginning is we had the square root of y squared. So in this case, the square root of x squared at the beginning, the square root of the second term, which will be 5 at the end, and then 1 is plus and 1 is minus. That's all you have to remember for the difference of two perfect squares. All right. Now, here again, we see two terms. So our first thought is, oh, can it be difference of two perfect squares? So then you look, are these perfect squares? And they are, because the square root of 9z squared is 3z. The square root of 9 is 3. The square root of z squared is z. So the square root of 9z squared is 3z. The square root of 16w to the fourth is 4w squared. So again, thinking about what is 16, the square root of 16, and what is the square root of w to the fourth, which is w squared. And then we know that one of them is going to be plus and one of them is going to be minus. All right, last problem for this type of practice. So here we've got two terms, and so you should be thinking, okay, I'm looking for perfect squares. And you look for perfect squares and you notice, 50 is not a perfect square. And you're thinking, well, 25 maybe, but it's not that, and 2 is not a perfect square. Didn't Miss Connor say something about we have to do something first always? You always need to look for your greatest common factor. That was your first test. Did you catch it? You always need to check for your greatest common factor first. So go in and take out your greatest common factor, which in this case is just 2. Now here's the thing. Do not just throw it away. It's really important. We're not solving, we're not getting rid of things. We're just rewriting this expression in a different way. So don't just get rid of the 2. The 2 has to stay there. The 2 is a crucial part of this equation. It just goes to the outside. That's it. Okay. Now we can look and say, okay, we've taken out the greatest common factor. Can we factor this any further? And we're still going to say, okay, there are 2 terms, and 25 is a perfect square, a squared is a perfect square, b squared is a perfect square, and it's separated by a subtraction. So difference of 2 perfect squares. I would like for you to figure out or try and factor this on your own. So taking the square root of 25 will give us 5 at the beginning. Taking the square root of a squared, b squared, we get ab, and then we just have a plus and a minus. You still have to keep the 2 in front because that's a crucial part of the original equation. If you got rid of it, it would now, sorry, not equation, expression. If you got rid of it, now it would be a different expression.